All right, today let's talk about polymorphism. Now, polymorphism, what is it? We've looked at inheritance, where we talked about the superclass and the subclass, right? The subclass inheriting or extending or deriving, whatever terminology you want to use there, from the superclass. So polymorphism is an object-oriented concept. It's a fusion of two words. The first is poly, which means many, and the other is morph, which means form. And so if we merge those words together and try to make something up for polymorphism, we say polymorphism is many forms. And what does that really mean in more technical but simple term is that it's when you have a single action that can have different implementations depending on the object performing it. Now, you don't have to wrap your head around this. I hope I break this down so you understand what it really means. So, but the key things I want you to take note of as we keep going is this word single action and different implementations. Those are the key words I need you to pay attention to as we keep going. And let's just take a look at an example. So we have pets. Right? Some people have dogs, some people have cats, some people have fish, some people have birds, some people have different parrots. And let's say we know all these are pets. And we know that these pets have attributes such as name, breed. Right? So if you have a cat at home, the cat has a name, the cat has a breed. If you have a dog at home, the dog has a name, the dog has a breed. And then we talk about the behaviors, which is what the dog or what the pets do in general. So all pets sleep and all pets eat, all right? And let's say we want to have a cat. We have a cat. The name of the cat is Luna. That cat is a pet, all right? And we can also have a parrot called Tweety, and Tweety is a pet. And we have a dog called Jax. Jax is also a pet. Now you'll notice that all these, even though they are all pets, but they are different animals. And now let's say we want to have a method to, make Luna do something. So we want Luna to make sound. And we can have a method called meow. And when we write that method, all we want to do in the context of programming is just to print meow. And when we want Tweety to make noise or to say something or to make a sound, we call that method called squawk. And when we print something, when we print that out, what we print out when Tweety squawks is the word squawk. How about Jax? You ask it to bark. What happens? We have this woof sound. Now, what do we notice about all these things? They're doing essentially the same thing. But what do you notice? When a cat says meow, it's only making a sound. When a parrot squawks, it's making its own sound as well. And so when a dog barks, it's also making its own sound. So rather than have, these three different method names, how about having a behavior that we can now say make sound? And so if we add that behavior called make sound to pets class, we can then go ahead and replace this method. For instance, we say make sound, replace that meow with make sound. And equally, we can call make sound on Tweety. And we can also ask the bark, well, if you're going to bark anyways, why not just, let's say, make sound? Now, what do we notice? We see make sound. For Luna, we see Tweety making sound. We see Jax making sound as well. Now, let's get back to our definition of polymorphism. We said it's a situation where you have a single action having different implementations depending on the object performing it. And let's recall that from the previous example, the single action there was make sound. So we can say, hey, Tweety make sound, and Tweety just squawks. When we say Jax make sound, Jax does woof. And so if we call make sound on the cat, it prints meow, and we call the same make sound on the dog, which is in this case Jax, we print woof. So where does this lead us? Let's take a look at another example. So we have different kinds of shapes, right? And these shapes have their attributes. They also have their behaviors. So the attribute of a shape could be that a shape has a name, a shape has a color. And what can that shape do? We can paint the shape, but we can do other things as well. But now we say a circle is a shape, a triangle is a shape, a diamond is a shape. Now, something is probably ringing in your mind when we said is a, and if this word right here, inheritance, is what you thought of, then you're absolutely correct. If not, yeah, it's not a problem. You'll understand it even by watching this video. So let's see, what does inheritance mean? We just mean we have a superclass of shapes, right? And shapes can be any kind of shape, right? And now we're saying circle is a type of shape. And the circle in this case would be a subclass. And so in Java, the way we represent that is by saying a subclass extends a superclass. Superclass in this case is shape. So what does this mean for us in the case of polymorphism? So let's say we want to draw a circle. We can say we want to define a method in the circle class that, is draw circle. And when we call that method draw circle, we get a circle drawn for us. And we call draw triangle, we get a triangle. We call draw diamond, and we get diamond. But what do you notice now? We're doing one thing, the same thing. What are we doing? We're drawing, we're drawing, we're drawing. So whether it's a circle or it's a triangle or it's a diamond, all we're doing is just drawing. And so rather than have three different names for all these methods, why not just include this draw behavior in shapes? And the inference, and what that means is that we can now, back to this place where we say subclass extends superclass, we can now call draw on circle and then have a circle drawn for us. We call draw on triangle, and we have a triangle drawn for us, and we call draw on diamond, and diamond gets drawn for us. This here is a concept of polymorphism. Now, before we go into actual program, let's take a look at this, because if you notice, we're saying one method, and if you notice, it's the same method signature, no difference. So let's talk a bit about method overloading and method overriding, and then we'll switch into programming where we see how polymorphism works. Well, not too complex, but just the basic things you should at least know about polymorphism. So let's look at method overloading. We have multiple methods with the same name, but different parameter lists. So essentially, we're saying that we have multiple methods. These methods have the same name. So you can have something like, draw, and we have draw something else. But we'll take a look at an example here. But what I needed to pay attention to is this, that you have multiple methods. These methods have the same name, but they have different parameter lists. So let's take an example here with this method, add. Notice that within the parentheses, we have two integer parameters, all right? If we want to overload this method, we can have another method here, say add, and within the parentheses have double, double, double. Now, if you notice, we have different parameter lists, right? We have double, double, double. We're not just looking at the number of parameters that we're taking in, we're also looking at the type of parameter we're taking in. So if we were to have double, double, that would still be an overload because this is an integer, but if we have double, double, that would be an overloading because we have different parameter lists that this same method with the method with this same name calls or refers to. So here we say the method signature matters and they are resolved during compilation. And so because of this is actually called compile time polymorphism. Now, there is the other type of method that we override method. So this is method overriding. For method overriding, it turns out that there is that child class that overrides. Again, we're not supposed to do this, but when you think of this word override, it's like saying we have the same method with the same name, with the same parameter list, or if you want to put it more technically, would be the same method with the same method signature. So in the case of our example, we had draw in the superclass, which is shape, and in circle we have a method as well called draw. In diamond we have a method called draw, and what we're doing, because shape is a superclass and diamond is a subclass, when we have draw for shape, and we'll take a look at this in programming, so don't bother about this abstract explanation that I'm trying to give. It's just to make you understand what this really means. So when we have the same method name that has the same method signature, and we have one in the superclass that, and we have another in the subclass, the same name, the same method signature, what we're doing is we're overriding that method in the parent class. So let's take a look at an example. An example would be the same make sound example that we used. So we have the pet class, right, with a make sound method. And we have a cat and dog classes. If we have cat and dog classes, and we call make sound as well, we implement a make sound method as well, or we define a make sound method as well in these classes. What we're doing is simply overriding what we already defined in the pet class. And the reason is because the pet class in this example is the superclass, while the cat and dog are subclasses. So you think of it like this: a cat is a pet, a dog is a pet. And so one thing to note is you should use the @override annotation, and this is not strictly necessary. It's just that it's something that is advised. So I encourage you to always, when you override a method, have this @override annotation. Now in Java, this is resolved at runtime using dynamic method dispatch. And we won't go into complex details of how this works, but I just need you to know that this is called runtime polymorphism. And so we have two different kinds of polymorphism, right? The compile time polymorphism, which is what we looked at before, method overloading. And now we're talking about the runtime polymorphism. So let's go over to actual program. Now, we'll take a look at the shape example. So we know we have a method. Let's first create a main method. I'll call that main. It's a class. It's fine. I want to add it. And before we leave this place, let's just have a main method here inside this main class. Public static void main string args. All right, we'll come back to this class later on. Now here, remember, we have shape, which is the superclass. So let's define that superclass first. I'm going to call this shape. And we need 3 more classes. The first, let's have circle. The other, let's have triangle. And this is just from the example of the shapes that we looked at. And finally, we have diamond. All right, so we're done with this. Now, what did we say about circle, diamond, and triangle? All these. So for instance, the triangle is a shape. And so because we're saying is a shape, we want to say extends shape. And same thing applies to diamond. So let's go to diamond and let's say extends shape. And let's go to circle as well. And let's say extends shape. All right, so that's all we have to do here. And again, this is not a complex thing, and this is just to demonstrate in a little way. Hopefully, this makes things clear. Let's go over to shape, and here, all we want to do, and we're keeping things simple here. We're not defining any constructor. And recall that we said if we don't have any constructor in our class, Java provides one for us. The one that Java provides for us is called a no argument constructor. And so there's nothing within the parentheses of that constructor. And so we're not going to have we won't have any constructor here defined by ourselves, but definitely Java provides one automatically for us. So let's go ahead and create this method called draw. And we'll call this private void. And let's call draw. In draw here, all I just want to simply do, let's just print out we are drawing a shape. All right, so semicolon right here. It's telling me I have something, rename reference. Do I have a problem somewhere? All right, before we move on, let me just quickly instantiate this shape object. So I'm going to call this shape1, or let me just say this is my shape, equal to new shape. And let me just call my shape.draw. And now if this prints out correctly, then we don't have a problem. And as you can see, we are drawing a shape. Okay. Now, let's get back to circle. So in circle, we want to have, remember, we said we don't want to call this method draw circle. We want to have the same name. So we already have, in this shape, we already have this method called draw. And in circle as well, we can also say we want to draw a circle. So if we want to draw a circle, all we just need is just to call that method draw. So here we want to say public void. What do we want to do? Draw. So rather than call draw circle, we just want to call draw. Now, because we are overriding a method, now this is what, and now pay attention. This is where we're talking about overriding. Notice how that this method here is the same thing as what we have here. Now, how would overloading be a different thing? Overloading would be if we had another method here, we say public void draw, and we pass in a parameter here, and we're saying maybe int x, maybe the x coordinate. And we can have another one that says draw. And this time around, we want to pass in not just the x coordinate, but we want to also pass in the y coordinate. Now, what did you notice about this program? When I stopped here, you can see the squiggly. And what's it telling me? It's telling me, hey, what you're doing is wrong. I don't know what exactly you mean to do, but this draw int is already defined in shape. You can't possibly have two kinds of draw. Well, if I change this to double, it's going to tell me, okay, that's still fine. So if someone passes in an integer, I would use this one. Otherwise, if they pass in a double, I'm going to use this one. So again, like I said, even though you see this is draw and you have just one parameter, right? You have one parameter here as well, but what data type is this parameter? This is double, this is integer. And so it knows that this is still overloading. And so this is overloading here. And I'm just stressing this so you understand the differences between overloading and overriding. And so we can say int x, and we can say int y as well. This is overloading. Let's say we want to still have another method called draw. We can say public void draw. And what we want to do is, rather than take in, maybe we want to say, okay, if a person passes in double for the x coordinate and double for the y coordinate, we want to use this method. So notice how that there's no problem, right? This here is what we refer to as method overloading, where the method signatures are different. And by method signatures, we just mean the name of the methods are the same thing, draw. Within the parentheses, we have different, so we have two parameters here, right? We have two parameters here as well, but they are different because their data types are different. And so again, we can also have double int, just so you know, there's no problem with this because this is int, this is double. And in fact, we can also say int double. And there's no problem with that because, again, there is no other method here that takes in an integer and double. What we have here is a double integer. So it's looking at this from the perspective of, is the data type here the same thing as this one? So if so, okay, let's go to the next one. Is this one the same thing as this one? No. All right, so this is overloading. You don't have a problem. I hope I was able to sufficiently explain that part. We're not using overloading here, so I'm just going to get rid of all these methods for now. Now, this is what I want to show you. For overriding, we have a method here called draw. And now that I have already explained what the method signature is, notice that we're not passing in anything into this parameter list. So if we had something like int x, this here is a different kind of method altogether. In fact, let's go ahead and say we're overriding, override. And now when we do this, what do we get? We get this squiggly. What is it telling us? It said method does not override method from its superclass. Why is it saying this? It's simple because we're passing in a parameter here in the superclass, which of course, if you take a look at this, it's inheriting from shape, but in the superclass, we don't have any such method that passes in anything. So take a look at this again. We have int x. If we want that squiggly to go away, this right here, all we need to do is just to have int x here. And you don't have to type this. This is just to explain. And it doesn't have to be x. It can be anything. So it can be num. The name doesn't matter. What matters is this data type. So pay attention. And now you can see the squiggly is gone. Nonetheless, that's not what I want to do, so I'm just going to get rid of this. And now you can see the squiggly again telling me, hey, we don't have any method like this to override. So let's get back here and let's just restore this to what we had before. All right, so let's get back to this place. What do we want to do here? All we want to do is just to print out this shape called circle ahead of time because I don't want to take time doing this. I already have this written somewhere. And so I'm just going to copy this system.out.println. I don't want you to watch me typing all this, but I'm going to paste that here. And so if all things work correctly, we should have this shape out for us. And maybe before we do that, let's just say system.out.println printing a circle. ... All right, and let's just have okay, right here at the end, I just want to have a new line so that we can have two different lines there. All right, so that's essentially what we have in this draw method. Now we go over to diamond. We also have the same method, public void draw. And again, notice that we didn't pass anything into that parenthesis, right? And here we want to, again, I said it's a good habit. It's a good habit to say at override. Now, it's not like if you don't, it's not going to work, but it's a good habit you want to get into. In case you make any mistake, typing out your method, then it's going to yell at you that, hey, we don't really have anything called draw in the superclass. So let me show you what I mean by that. So if I have draw int x, remember the last time I got this squiggly on at override that tells me, hey, sorry, something you did here is not correct, right? But now I don't have that kind of error reporting functionality, and that's not too good because I can just keep working and I didn't know that I made this error. So I'm gonna get rid of these and we'll have at override here. So it's a good practice. For diamond, I'm just going back to printouts and I would just copy that of diamond. So I'll just copy this. Like I said, it's just a very simple program. You can pause and try to type out the same thing. It's just, these are just spaces. All right, these are spaces. So you want to just make sure that when you write the system.out.println, you have spaces in between these quotes, and you can type this out. So finally, let's head over to triangle, and we'll create the same. We'll define the same method, public void draw. In this method, we want to draw a triangle, and I'm just going to go ahead and copy this again. And that's all, because I don't want this to be too long. So let's head over to triangle, and we'll paste that right here. And let's also have something here that says system.out.println printing triangle. Triangle, ... in \n, just for us to have a new line there. And finally, let's do this as well. System.out.println printing, oops, that should be in quote, printing diamond, ... All right, so now what do we notice? We have draw method. In diamond, we have draw method. In triangle, we have draw method for circle. Now, we also have a draw method for shape. Because we don't know what the shape is, we just say we're drawing a shape, but we don't know what the shape is. Now let's head over to main.java. And this is where I want to really show you, because again, you might just be like, hey, so what are we really talking about here? So where's the polymorphism, or where's the polymorphic behavior? Now let's say we have this shape, my shape equal to new shape. That is not new to us, right? It's just like saying we have circle, my circle equal to new circle. Well, that is not new to us. This is something we've been doing before if we want to instantiate a circle object, right? We can also say triangle, my triangle equal to new triangle, right? Well, this is not new. This is something we've done before. So my diamond equal to new diamond. Okay, so what's the polymorphic thing here? Nothing looks different. Now, what if I told you that we can now say shape circle equal to new circle? Now, up until now, we haven't seen anything like this, right? When we call shape, we know that the next thing to call here is a constructor that is defined within the shape class. However, this is where polymorphism comes in. We have this shape, and we have this reference variable called circle. The reference variable circle is of a shape class. And so it's like saying, hey, this is going to be a shape. We don't know yet what that shape is going to be. So at this point, when we say shape circle, that's like saying, hey, we want a shape, the name of that shape is going to be circle. We don't know what the object is in that circle just yet. And remember, the reference variable do not point to the object directly, right? They point to the memory location where the object is contained. And so now we're saying, hey, this circle, we want to have a new object created. We want to instantiate an object, and this should be from the circle constructor. So that's more like saying we're calling the circle constructor, or we're instantiating a circle object, if you will. But isn't that correct? Yes, because a circle is a shape. And so if we say shape, which is the more generic, more generic form of shapes, it can be a circle. And in fact, we can also say shape. We can say shape diamond equal to new diamond. And this is absolutely okay. We can also say shape triangle equal to new triangle. All right. So up until now, we've not seen something like this. And finally, we can also say shape. Shape. I don't know if that's okay to do, but shape. Hopefully that's not confusing to you. Equal to shape. What do we see here? So we can have a reference variable that is built, or that is of the class shape, refer, which is the superclass. So we can have this reference variable, which is of course from the superclass, refer to or point to a memory location where we have these, different objects. These objects could be from the superclass itself, which is in this case, as is in this case, or it could be from the subclasses, as is in these other cases. So what does this mean for us? We've not yet called the draw method. How is this even useful for us? Now, we can have an array of shapes. So let's say shape, and we have this shapes array. We can now say we have an array of shapes. Let's just call this shape. Let's call this circle. Let's call this diamond. And let's call this triangle. And we can now go ahead to iterate over this shapes array. And let's use an enhanced for loop, what is also referred to as the for each. So we can say for. When you're using the enhanced for loop, what you need to pay attention to is this here. So whatever is here, just copy that and paste that right here. And this name, if you will, you can also copy it here and paste it here, but just get rid of the plurality of that name. And then the next thing here is shapes. Now, but because we've used shape somewhere here, let's turn this to shape 1, just so we don't have any issues with name clashes. All right, so now we have shape, which is coming from this class. This is the variable that we are holding each of these items in. Of course, all these as well are reference variables. And we're saying these are all types of shapes, which is also from here, this array of shapes. Now, what can we do? We can go ahead and then, let me comment this out. Oops. Let me comment this out. And we can go ahead and say shape.draw. Now, notice how that we're calling just one method, draw. If we had written draw cat, if we had written, if we had written draw circle, draw triangle, draw diamond, then there won't be any way for us to call this one method in this array. I hope that makes sense, because we probably would have to start checking. Are we instantiating a circle? Are we instantiating a diamond object? We have to start checking that here. So rather than do that, why not just have a method that has the same name, but when we call them, they do different things? Let's go ahead and run this program and let's see what happens. And when we do this, what do we see? Let me just take this up. And now, what do we see? We're drawing a shape. That's the first. And let me see if I can actually contain this. So let's look at this. We're saying we have an array of shapes, right? And if I hover over this, this is public class shape, as you can tell. And we're saying now we have circle, we have the shape 1, which is, of course, the shape itself from the superclass. That's a reference to the object. And we have a reference to the object, the circle object. We have a reference to the diamond object. We have a reference to the triangle object. And we're taking all of those and we're drawing, we're calling this method draw on all these objects. So now for the first one would be the shape. For the second one would be this circle. And that's why we have this printing a circle. And the next one is diamond. That's why we have printing diamond. And the next one is triangle. And that's why we have printing triangle. I hope this is clear. But this here is just a simple way that, you know, we can make use of polymorphism. And this is one way that, you know, like I said, it's more complex than this, but if you can, you know, take some time to understand how this really, you know, what's really happening, and if you have any question as well, you can let me know. And in fact, notice that again, I won't print out my shape, but let's go ahead and print my circle, my triangle, my diamond, and let's see what happens as well when we try to do that. My circle, my triangle, my diamond. So when we do this, let's go ahead and run this program and let's see what we get. Now, notice that we now have these shapes printed twice, even though, so notice we have printing a circle, printing triangle, printing diamond, and we have those twice, all right? Printing a circle, printing diamond, printing triangle, and that is because, look at this place, look at this. Even though we said this is a circle, this is a reference to the circle object. We just don't know what it's. I mean, this is going to be circle, right? We're instantiating a triangle, and we're having a reference here for triangle. So again, this is what we've been doing before, but now we're saying we can also do this, where this is the superclass and this is the subclass. Now, let me mention this. You can't do this the other way around. So we can't possibly say triangle, wrong triangle, equal to new shape. We can't do this. And as you probably have noticed, it tells me, A, cast expression to triangle. And so if you want, you can't do this. And the reason is because, now let's take a look at this for a moment. We have wrong triangle, which is a reference to a triangle object. Whatever that is has to be a triangle. But here we're saying new shape. Now when we call new shape, recall that shape is a superclass. And because it's a superclass, it can have several types. So a shape can be circle, a shape can be triangle, a shape can be diamond. But how do we know exactly what type of shape you're talking about here? And so because of this, it's really confused. And so this makes it wrong. Even though we're looking at this, we're saying, okay, this has to refer to a triangle, all right? This here has to refer or point to somewhere in the memory where a triangle is, where we have a triangle object. But what's happening here? When we say new shape, the new shape can be a new rectangle. So we can't possibly say a triangle is equal to a rectangle. That would be wrong, right? And so that's what makes this wrong. And so this is incorrect, and you want to pay attention to it. When you have something like this, you're starting with the superclass, as in this case. Of course, this is possible because shape can be anything. And so when we say new diamond, oh yeah, it just knows that, oh, okay, so we have a diamond, we can have diamond as a shape. I hope this is clear. If part of this video isn't too clear to you, you may please let me know in the comment section. Otherwise, you might just want to take some time, just pause, rewatch, play around with things, look for different example, practice, and see how it works. Maybe one thing I would ask you to do is to take the other example of cat, parrot, and dog example and try to have a mixed sound, just for you to have something to chew on. Now, finally, in this video, what I want to show you is that rather than have new shape, new circle, new diamond, new triangle, we can now go ahead and let me just comment this out and just have it somewhere else. And we want to have an array of shapes. And rather than, in our array list, rather than have, shape 1 equal to new and all of that, we just want to, do this directly. We want to have new circle, we want to have new diamond, and we want to have new triangle. So again, what are we doing differently? We're just, saying, okay, we don't need to have these reference variables. We can just, just instantiate or just create that object here for us. And this will still be good to go, because again, what we're doing here is just like saying, okay, this is a placeholder, right? This is something. This is a reference, to the memory where this object is instantiated. And so what we're doing here is just instantiating the object and just passing that reference to this array here. So let's go ahead and run this and let's see how this works. And if all things work well, we should still have the same, exact same output. We're drawing a shape, printing a circle, printing diamond, and finally printing triangle. And if you want to, let's get rid of the new shape. And just so you see, this is just so you understand that this is coming from, so we shouldn't see this, we are drawing a shape anymore because we've taken out that from the array. So let's look at this. You can see printing a circle, printing a diamond, and printing a square. All right, so that's it for polymorphism. Like I said, it's much deeper than this, but basically this is what it means. So we have just one method. Again, back to our definition, we have just one single method called draw. But when we call draw on circle object, it draws a circle. When we call draw on diamond, it calls, it draws diamond. All right, so I'll see you in the next one. Until then, keep practicing. Bye.